Hello friends, welcome to my channel PH Chemistry. Today we are going to talk about Friedel-Crafts reaction. So there are two types of Friedel-Crafts reaction. First is the Friedel-Crafts alkylation and second is Friedel-Crafts acylation. As the name suggests, alkylation means any alkyl group gets attached to a benzene ring, and acylation means any acyl group gets attached to benzene ring. So in this video we are going to talk about Friedel-Crafts alkylation basically, and in next video we'll talk about acylation. So what is Friedel-Crafts alkylation? Friedel-Crafts alkylation is a electrophilic substitution reaction. What is mean by electrophilic substitution reaction? Substitution reaction means any one atom or group is substituted by the another atom or group, and electrophilic means there is a substitution of electrophile by any atom or group. So this is the electrophilic substitution type of reaction. I'll write any reaction of Friedel-Crafts alkylation. When this benzene react with any alkyl halide in presence of anhydrous AlCl3, the product will be derivative of benzene and hydrogen halide. This is the reaction of the Friedel-Crafts alkylation. Here you can see the alkyl groups get attached to the benzene ring. Substitution of hydrogen from benzene ring is by the R group, means alkyl group here is taking place. This hydrogen gets attached to this halide. So why anhydrous AlCl3 is used? The anhydrous AlCl3 is a Lewis acid. It is very deficient, so it takes the electrons from the halide and form electrophile. So we'll see in the mechanism what is going to happen. So the mechanism of this reaction occurs in three different steps. First step is the generation of electrophile. In the first step, electrophile is generated. So how the electrophile is generated? I am taking methyl chloride here. When this methyl chloride react with anhydrous AlCl3, as I told you, AlCl3 is Lewis acid. It is rarely deficient, and this chlorine contains 3 lone pairs of electron. This chlorine will give its electron to this aluminium, and this species is formed. This is the intermediate. This is really fast reaction. Partial positive and partial negative charge form here. This chlorine will remove after some time, and CH3 positive, this electrophile is generated, and AlCl4 negative. Now you can see here the electrophile is ready. Now this electrophile is going to attack on the benzene ring. So the second step is the attack of electrophile. So now we have a benzene ring and an electrophile, which is methyl. Now this double bond will shift here. When this double bond shift here, negative charge comes here and positive charge will comes here. So CH3 will attack on this negative charge, and we'll get this double bond remains same. CH3 attach here and the positive charge comes here. Now the positive charge is on benzene ring. It will and the double bonds are in resonance. it will try to stabilize this positive charge. So this double bond shift here. When this double bond shift here, we get different resonance structures. This positive charge will come here, CH3 will remain as it is. Now again this double bond will shift here to stabilize the positive charge, and this positive charge now comes here, double bond will shift here, and CH3. These are the resonance structures. All these are the resonance structures. Resonance structures are always shown by double-headed arrow. The double-headed arrow means resonance structures. So what will be the resonance hybrid of these structures? Resonance hybrid will be, as the positive charge is moving all over the ring, so we can write the resonance structure as like this. It is also known as sigma complex. This is a resonance hybrid, and these are the resonance structures. So the last step is removal of proton. Proton will remove. So we take this resonance structure. Positive charge is present here. When AlCl4 takes this proton, the negative charge comes here. So positive negative will forms double bond. So we'll get our final product, which is toluene and HCl and AlCl3. So AlCl3 is recovered in this reaction, HCl is a byproduct, and our product is toluene. So our product is toluene. So in this way the mechanism goes. First the generation of electrophile, second is the attack of electrophile on the benzene ring, and third is the removal of proton to get the final product. Now you will get it more clear with the examples. So let's see some examples. So these are some examples which we are going to see. Before seeing the example, I will tell you why the anhydrous AlCl3 is used. Anhydrous AlCl3 means without any water molecule. As I told you, AlCl3 is Lewis acid, so it is rarely deficient. It wants electron. If a hydrated AlCl3 is used, hydrated AlCl3 means AlCl3 contains water. Now water contains oxygen, oxygen having two lone pairs. If the hydrated AlCl3 is used, this will take lone pairs from here and it will not form any electrophile with this alkyl halide. So because of this reason, unhydrated AlCl3 is used in this reaction. Now we will see the first example in which we are using benzene ring, and this is the isopropyl chloride. So now what happens, simply just remove HCl, remove the hydrogen from here, remove HCl, so remove the chlorine from here and hydrogen from the benzene ring. Our product will be like this. This is known as isopropyl benzene, or it is also known as cumene. This is the product. Simply remove HCl from the reactants and the product is formed. You can attach this at any place of the benzene ring as it is symmetrical structure. So this is very easy. Now see the second example. Here this is the benzene ring, this is N-propyl chloride. This is N-propyl chloride. In presence of anhydrous AlCl3, Friedel-Crafts alkylation will take place. So now if we remove HCl, Cl will remove from here, hydrogen from here. The product form is again cumene. Product form is again cumene. So why it happens? This happens because of the fact that, as we know, tertiary carbocation is more stable than secondary carbocation, which is more stable than primary carbocation. If you remember the mechanism of this reaction, carbocation is formed in the N-propyl chloride. This type of carbocation is formed, which is a primary carbocation. Here what happens is 1,2 hydride shift will takes place. This hydrogen will shift here, so the secondary carbocation is formed. And as I told you, secondary carbocation is more stable than primary carbocation. Now this carbocation will attack on the benzene ring and this product is formed. So note it down here. This is the note number 1. Whenever there is a possibility of the formation of more stable carbocation by the any proton shift or by any atom shift or group shift, then the more stable carbocation will form and the product will form with the more stable carbocation. Okay, now see, this is the example of proton shift. Now we will see the example of the group shift. Next is the example of group shift. The carbocation form is like this. This is the primary carbocation. Now this CH3 will shift here and the carbocation will rearrange to a tertiary carbocation. This is the tertiary carbocation. Now this tertiary carbocation will attack on the benzene ring. So the product is this carbon attached to CH3, which is attached to second CH3, CH2, CH3. The product is this plus HCl. Okay, this is the product. So again, note number 2 is what? Group shift. It is a group shift example. First note was of the proton shift. Second note is of group shift. In this example, as I told you, when there is a possibility of more stable carbocation, so the carbocation will rearrange. Product expected is like this, but the actual product form is this. This is expected, this is actual. Why it happens? This is expected product and this is actual product. Why it happens? Because anhydrous ZnCl2 is used or anhydrous FeCl3 is used. In all the above examples, we have seen anhydrous AlCl3 is used as a Lewis acid. But here you can see anhydrous ZnCl2 and anhydrous FeCl3 are used. So what is the change in the reaction? The change is, if the anhydrous ZnCl2 or anhydrous FeCl3 are used, there is no possibility of rearrangement. There is no possibility of rearrangement. Here primary carbocation is formed. So primary carbocation directly attack on this benzene ring. It will not rearrange. It will not shift any atom or group to rearrange to form a more stable carbocation. So this is with only ZnCl2 and FeCl3. So Noted here, this is the note number 3. Whenever ZnCl2 or FeCl3 is used as Lewis acid, no rearrangement takes place. No rearrangement takes place. So the fifth example is, here we took a chlorobenzene as a reactant, methyl chloride and anhydrous AlCl3. So what will be the product in this reaction? First we will see the mechanism. When this methyl chloride react with anhydrous AlCl3, the electrophile is formed and AlCl4 will removed. Now this electrophile attacks on chlorobenzene. Now this chlorine contains 3 lone pair. It will show plus R effect, means plus resonance effect. This lone pair will shift here and this double bond will shift here. So this will form. When this will form or either this will form, or the second possibility is these lone pairs will shift here, double bond shift here and this shift here. So the second possibility is negative charge present here. Now what will be the third possibility? Third possibility is like this. This double bond shift here, this shift here and this will comes here. So we'll get positive double bond here and negative. So you can see the electron density is at ortho position here, here at para position, here again at ortho position. So the possibility of attack of the electrophile is only at ortho and para positions. This electrophile can either attack on the ortho position or on the para position. So we'll get two different products like this. This Cl will remains as it is. CH3 gets attached to ortho position in one case and it gets attached to para position in the another case. So the name of this is orthochlorotoluene. As chlorine is present at ortho position and benzene ring attached to CH3 is known as toluene, and this is parachlorotoluene. So which will be the major product in this reaction? Always parachlorotoluene will be the major product because of the Lewis hindrance. So it will be the major product in this reaction, and this will be the minor product in this reaction. So this is it for today. If you like the video, hit the like button and do subscribe to my channel. I will meet you in the next video. Till then, thank you so much.